Well, hello everyone. So this will be part 5 of our coding of production style C++ application for Windows using Win32. I decided to write this follow-up. First of all, I want to fix a couple bugs in our existing code, and also I wanted to write a Test Fuzzer application. Now, if we look at our current application, again, it's this SigRemover. It's a C++ app. So if we load it up, and if we go into our actual function that processes PE file, as you can see, all this stuff here is technically parsing of a file. And since we don't know which file the user might be sending us, there's a possibility that we might have made a mistake in this parser. Now, parsers and deserializers would be, those specific parts of code where it's so easy to make a mistake. Like even though we have like all the checks for overruns, checks for signature and such, this is still possible to make a mistake. Now, one way would be obviously to go through your actual logic and check it again. And another method is to write a small external application that will throw, well, some random input into your program and see if it crashes. This is the principle of a fuzzer. Okay. Now, before we go any further, we need to actually check and fix one bug in here. Now, if we search for the operator new, let me just go and do the search. Now, the thing that I forgot is that the new operator that we have here actually comes from STL. And what this line is doing is that it will allocate this many bytes from the heap, and if it fails to do that, it would not return null. As I'm checking here, this version of new would actually throw an exception, and that would be a problem because our app, since it doesn't have any way to catch those exceptions, again, I was relying on it returning null, it would crash the app. So that is not good. So we need to fix this, and what we need to do, let's just do over here, we need an include, not mu but new. It's just something that we can use here, and we need to add in parentheses std no throw. Okay, now this form of new will not throw an exception and will return null if it can't allocate memory. Okay, so we need to do the same. We need to scroll and see where else we have the same operator. Oops. So the same here, we're expecting null. And let's see if we have anything else. And we do over here. So, and that, let's make sure that there is no more allocations like this. Okay. So as always, because we are working on a production version and it's a new one, we have to update our version number, and also here globally. And let's make sure that it builds. And it does. Let's make sure that we don't have a command line here. We do have a command line. So let's remove it and run it. So we have a new version. Okay, so now when we fix this bug, we can actually write the fuzzer. Now, before we do this, we need to adjust our code a little bit. So if we look, let me just go back. If we look at this part of the code, when we process the contents of the PE file in memory and then we return success, over here we actually write it into a file. So what I was thinking to do, if we can write some kind of test app, external app, that would literally go through all files in the system and kind of like throw them into this SigRemover app. Obviously, big number of them would not even be PE files, but what this will help is kind of like it would let us simulate all kinds of random input into the program. Well, if we do this, we obviously don't need to create any files, because we will definitely mess up our system if we start overriding or creating a ton of new files, plus it will be very slow. So what I was thinking is to create a new build of the app that will be specific for fuzzing. Now let me show you how I would do this. I wouldn't be just modifying code like this. I would create a new preprocessor command, like over here, for instance, on the top, where we have all the global variables like the app name and version. I mean, not the global variables, global preprocessor definitions. So let's just create another one. Let's just call it fuzzing build, and let's put a comment. We'll always remember to do this, and we would say uncomment to generate a fuzzing build, not fizzing build. Man, what's wrong with my typing today? Okay, so by default, when we build our production app, this will be set as such. So what this will do, it will just remove any fuzzing details. Now, if it's uncommented, like it says here, then it will create a special build for us. Now, before we go into into any modifications, we need to do a couple things. First, let's just do the obvious. Let's go to the very top and say, you know what, let's just do it like right here. If def, so if this preprocessor variable is defined, we want to let this be known in the UI that we are building a fuzzing build. Man, typing, I'm sorry, it's just all over the map. Okay, so what this does, in this case, if it's a fuzzing build, we should see it in our UI. In other words, when somebody, before running any tests in the production version, it will tell us, hey, don't release it to the customers, because this is a fuzzing build. Okay, now this part is important. Okay, so now let's modify our actual code. So in this case, if we have success, right, so we don't need to do any of this. So in this case, it's if in def. So in other words, if it's not defined. So in this case, we just don't need any of this stuff, right? So and if. And what this will do, will basically not create a file. So if we got success and we get here and pretty much don't do anything, don't write the file, just assume success, because again, writing a file is not a problem for us. The problem again is, well, not the problem, but the real test is in this function when we process PE file. And also, if we go here, let's look at the processing itself. So we check size, which is fine. Size here is also fine. What we need to change here is what happens if we don't see NT signature, because over here it basically cuts off all this stuff. But for the fuzzing, we actually need to not do this. In other words, allow files that don't have NT signature to go through. So in this case, we will also try all this stuff, which will just broaden the scope. Okay, so let's run it, and let's see, let's make sure it runs, and just for the sake of test, let me just do this. You know what, let's just take, maybe not. How about we take this path and plug it into our app. Let's just say and let's get the name of the process. Now, since we're not modifying anything, it's okay to just do it here in place, because again, it will not create a file, and this is a test for us. So if we run it, it just went through just fine. So let's go and double check. We go here and put a breakpoint. So as you can see, we got our PE file with MZ in the beginning, and we got success. And if we look closer, the file still has digital signature, so we didn't overwrite anything. Okay, so at this point we have our app ready. And now let's write the fuzzer. Now to do that, we need to start a second project. Now to write a fuzzer, I will not be using C++. Instead, I will be using C#. The only reason I'm using C# here is just to make it a little bit faster, because, you know, C++ is kind of like, you know, so it takes a lot of time coding stuff. C#, because it's just a fuzzer, we're not going to supply it to the customer. It's fine if we just write it that way. So let's do it. So if we search for console, now what we need is a C# console application, not for .NET Core, but for .NET Framework. Now the reason I'm using .NET Framework is because, you know, you might not even have this .NET Core, plus, you know, I kind of know framework. .NET Core is something new. So let's create console app .NET Framework. Now what we need to do, we need to put it into the same folder as our SigRemover. Now why do we want to do this? Well, we want to do this so that it's in the same project. I mean, in the same location in case we have to move it. And let's give it a name, SigRem Fuzzer. How about that? Okay. So what this will do, this will create a template .NET application for us. And if we look into the folder, here we go. Here's a SigRem Fuzzer. Okay. So at this point, we will need to write a simple app. Now, I'm going to write it fairly quickly, but I will explain what I'm doing. So, first of all, we need a static method that will return void, and let's just say fuzz file. Now, what fuzz file do, it will fuzz a file. Now, we need file path, and that will be the file that we're opening and that we want to pass into our SigRemover. Okay. Now in here we will create a process, and the process doesn't exist. So let's oops, come on, control dot, use system diagnostics. And let's say proc new process. Okay, so in the proc we need start info, and the file name will be the name of our executable. Now I don't want to hard code it, so let's see where it's located. Now if we build it, our app in the fuzzer is located here. So if we create a relative path, so we have to go 1, 2, 3, 4. Then we go into debug, and we'll use debug version of our SigRemover and debug SigRemover. Okay, so let's copy the name. And what we are doing, so we go SigRemover exe. It's a debug folder. And what is important is that we do this 1, 2, 3, 4 times. Again, that's kind of like a relative path to where we were. Here, we go from this file to our actual SigRemover exe. Okay. The reason we do this in case we move the whole project to a new location, so that we don't have to like recode this part. Okay, so then we need another start up info, and that is arguments. And arguments would be, well, obviously our I parameter. Then we need our quotes, and inside the quotes we need our file path. So that will be the arguments. Now we will not be concerned about escaping here of double quotes, because obviously we're not going to be passing them, since it's we are controlling the input. This application is not going into production. Okay, and we also need to hide our window, because if we start it many times, it will be popping into existence all the time, which is not good. Okay, so then we start our process and we wait for exit, and then we get an exit code from our application, and then we need to check exit codes. Okay, now before we do anything else, we obviously need a try and catch block, and we'll catch exceptions here. Now exception will be thrown if something happens when we run this process, and in this case we write console write line, and let's just output the exception. Let's just say exception, and what we're doing here, exception to string. That will give us the information about the exception. Again, we don't care about doing like cool fancy output. All we need is just this fact that exception happened, and we need to see what's in there. Okay, so at this point we are calling our app, our SigRemover, and we get the exit codes. Well, let's see what kind of exit codes do we get. Well, for that we get into the beginning. As we can see, exit code here is supplied by our application, and that is this enum. So what we can do, we can just copy it as is into our C# application. Probably we don't even have to change anything. Yeah, it just can be as is. And what we can say here is that this is the exit code that we get from our process. Now, what are we looking for? Obviously, we're looking for all of these exit codes, but there can be something else. Now, well, just to show you an example, let me just pass some bogus argument. Actually, you know what? I can't pass the bogus argument because I need to pass the actual path to the file. So let's do that. Again, that doesn't work. Let's see if we go here. So if we take actual name of the image file here, and let's see if we build it. I put a breakpoint and builds okay. So let's make sure that it actually starts the process. It does. It waits for exit, and we get success. Okay, so just to show what would happen in case our process crashes, let's kind of like fake the crash. Like for instance, if we go at the very beginning and just like, I don't know, just like let's do, we get rand and assume that this is a pointer. Now this is a crash. We just take some random number, turn it into an int pointer and read from it, so that will definitely crash the process. So just to show you, if I put a breakpoint here, you see it creates an exception, access violation. So let's see what happens if we invoke it from our app, from a Fuzzer app. So we run the process, we wait. Well, wants to debug it, but we don't want to debug it. What we're interested in is the exit code. You see, the exit code is something that is not in our enum here. And that's what we need to catch when we have an actual problem. Okay? First, before I forget, let's remove this crash and build it. So in this case, what we need to do, oops, not this one, but this one, we need to see that if the exit code is something that we don't have here, this means that there is a problem. Most certainly it's a crash. So, and additionally, what I also wanted to do, I also wanted to output, just kind of like count how many of these we are getting when we are doing our enumeration. And for that, we probably need a small class. Let's call it rem sig count stats. Just this kind of simple stuff. And it will have a bunch of properties. Let's say n count, and it has a getter and a setter. And let's say we will count successes. We will count situation where it's not a PE file. We will count when it's failed to open file, which might happen because of like access violation and stuff, and also when there is no signatures. Okay. Now what we need to do, we need to pass it into our function, but pass it by reference so that we get not a copy but the reference. And because we do this, it has to also come from somewhere, right? Let's just do it, I guess, right here. Stats, new stats, and pass it here, stats. Okay. And what we can do here when we are checking our exit code, let's say if exit code, let's see. Now, bad signature is a problem, so we're not going to be counting it. But has no signature is not a problem, because, you know, it's just pretty much any data file. In this case, we count as count no sig. Okay. Then we do else if exit code. Let's see. Okay, failed to write. Obviously, will not return it because we're not writing. Failed to open. In this case, stats will be failed to open. We incremented. Else if exit code. Now, general failure is something that, you know, we'll have to account for. Not PE file. Obviously, if it's a data file, it's not a PE file. Stats. We do not PE. And let's see, do we have anything else here? Oh, success. Yeah, well, in this case, we count success. And this part is the interesting one for us. Okay, this is where this needs our attention. Okay, and what we're doing, console write line, and then write line, let's just output some information like failed exit code, and make sure to provide exit code, and then we need to say in file and provide the actual file path. Now here we can output exit code that we got, and by looking at the exit code we can actually tell what happened, and also the file that we were fuzzing. Okay, so let's do this real quick to make sure it compiles, and in this case we should get let's see, we got success, and success count is incremented to 1, which shows here, which is nice. Okay, so at this point we can fuzz a single file. Well, we don't need to fuzz a single file. What we need to actually go and enumerate folders. So let's write little class here. And this is the reason why I'm using C#, because it's way more simpler to do this kind of stuff in C#. So enumerate folder, and this will be a recursive function. So it will take a string, which is, let's just call it folder path, and then we pass rem SigRemover stats by reference. Now this is important, we're not creating a copy, but just a reference. And so we're not calling this anymore. So in here, well, first of all, let's just make sure that our folder path always ends with a slash. And in this case, it's kind of like a not. If it doesn't end with the slash, well, then we need to add it. Oops. Now I'm really bad at typing today, so we need to add it. So this way we just make sure that the slash is always at the end. Okay, so then we need to use directory. If it's not available, let's add using system.io, and we need get files for our folder. Right? Now it will return an array of strings for us, and what might happen here in this case is that this may throw an exception if it doesn't have access to the folder. And why would that happen? Well, if we don't have let's say admin access. So that is why let's catch it. So and put that, we will create an external variable. Then we do a simple try catch block, but in this case we won't be catching all exception, but only unauthorized access exception. And in this case we'll just skip it. And what we need to do, we need to get it from here. So in case it's an exception, our file array will be empty. And then we can just say if it's not null, we will process it. Now the reason I'm doing it this way and not just enveloping the entire code in this exception is because I don't know if it will happen further out. All I'm caring here is just it happens in this part of the code. So in other words, I don't want to catch it anywhere else. Okay, and this we have just a for each statement here. Let's say string file in files, and here we will go through all the files that we found in this directory, which is very simple. Now I'm going to output it into a console, and I will set cursor at the top, make sure that it writes, you know, only to the top, and I would say console, not write line but just write, and I would put the file name, and at the end I will put spaces and a bunch of tabs. Just like kind of like we'll erase whatever is at the end of the file, because we will be writing them all at the top of the console, and I will just put a little bit of kind of like empty space after it. It's not going to look pretty, but you know, kind of like at least we'll make it readable for us. Okay, so then we can do the fuzzing of the file, and in this case we just call our fuzz file and pass our file into it and pass our stats by reference. Okay, and then output our stats. Now in this case we also do console cursor top. Now let's just say line 10, doesn't really matter. Console right. We don't need right line because again we're not, you know, we're not skipping down. And let's see, so what we can do is we can say success. We'll align it later. And here we can put our stats, and stats would be success. And we need several more. For instance, this one would be not PE. This one would be failed open. And let's see, I think we had another one, no signature. Let's make sure that we align all of them so it's a little bit better for us to see it. Okay, and here we're saying not PE, and here we're saying failed to open, and here it's no signature, so we need to remove this plus here. Okay, so at this point we will go through all the files in our directory, and then we need to see if there is any directories or any folders in this directory. So in this case, we just do this, and we have string file path. So this little for each statement, by the way, this should be string. This little for each statement will enumerate all directories in this folder. And let's see, in here we just call ourselves recursively. We just go like this. By the way, this is not for, it's for each. So what we will do, we will call the new folder and we will pass our stats by reference. Okay, and that should be it. Right, so again, we call ourselves recursively on every folder that we find inside, and then we keep going until we go through all the files. So all we have to do is just to begin enumeration, and we just have to pick where do we start. Well, we have to pass our stats. Well, let's just say that we start at the beginning. Okay. So just to kind of go quickly through what we're doing, let's put a breakpoint and start debugger. Let's go in. So we enumerate files, and as you can see, we found 5 in our C drive. And we go in. So here's the first file. Oops, we need to get this breakpoint out. So, well, let's see what kind of exit code we got. And we got not a PE file. So let's see what happens here. So we come out, we write the output. As you can see, well, there's a little bit of a problem here. Success got pushed out. Let's see why so. You know what, let's just put right line here. Actually not here, but here. Just we put carriage return at the end. Let's just try it again. So in this case we will not, oh, well, here you go, I just stepped in. So what happens here, as you can see, our enumeration keeps going and we are counting. As you can see, our app is giving us some output here. This is from the actual SigRemover, so that we can actually see what's going on. And we have our counts. So far, success, we have this many, and not a P, we have this many. But what we haven't done, because we haven't really put the breakpoint on where we have to break in case we have a problem, and we have two in this case. If we get here, if we have a failed exit code, or here if we get exception for our process. Let's just start over. Again, let's make sure that we have only two breakpoints, and then if we started, and now we can have our fuzzer fuzz our entire drive, and in this case see, like, we got bad signature and we have a file path. So something in the recycled bin, some kind of exe file has a bad signature. So what we can do, let's see, we can open a notepad, and when we catch this, we can copy value, we can paste it here, and we can say that this is bad signature, so that we can check it later. We can see what kind of a file is it and why did it give us bad signature. Now if we search by bad signature, if we search our original C++ project, we can tell that it actually comes from only one location, and that is where the image directory entry security directory is not formatted properly. In other words, if it's not at the end of the file. So this is something that we need to check. So in this case we caught it. Let's keep going, and this is how we can actually see where the problems are. So here we go, we got another one. Now I wouldn't be checking it right away. Let me see if it's immediately bad signature. Yep, bad signature. I would just document it. Again, you can probably write this internally from the C# app, but in my testing, in my fuzzing, it actually didn't generate too many files. But this is how you do it. Now keep in mind that this process would take a very long time. In my case, it took almost a day because I have a very large C drive. But in your case, it might take less time. But just let it run, kind of like check it once in a while and see what will happen. Now, just to kind of go back to this interesting situation of a signature being improperly added to a file, one of such files is actually this uninstaller for Mozilla Maintenance Service, which, as you can see, Windows doesn't even see that it has a code, that it has a signature. But if we pass it into our app, let me just show you what happens. We can do this here because actually we're not running the, we're not going to be building our C++ app. So we can still do it in parallel when our fuzzer is running. Okay, so if we provide this uninstaller for Mozilla, let me show you what happens. Let me just clear all breakpoints and run it. Okay, so the virtual address, let me just copy it here so that you can see. Right, so then we have a size, which seems like all right, but then it should be equaled to the size of the file. but the size of the file is way smaller than the offset for the PE signature, for the signatures directory. So they clearly misconfigured it. So that is why we get here and we get our, you know, exit code, which is bad signature. So this is kind of like an interesting find in this uninstaller for Mozilla Maintenance Service installer. So again, you will probably find a few files like this, so you can document them with your fuzzer. And yeah, so just let it run and see what it finds. The important thing for you is that it doesn't find any exit code which is not on this list. In this case, this means that you have a failure, a crash in the SigRemover app. Now, if that happens, the output or the breakpoint here will give you the file path, which was very important. In that case, you can take that file here, plug it into SigRemover, and see where the actual fault happens. This is very, indispensable information, and that will really help you with understanding your bugs. Okay guys, so at this point, this is just showing you how to write your own test fuzzer. And also I fixed one bug in my program, which I, by the way, found through the fuzzer. And this is how you do it. So thank you very much for watching, and see you next time.